Hi, this is Xiaochu at Lehigh University. For today's video, we are going to talk about the homework for week 13. Let's take a look at the first one. A levee is built to protect the construction work from the 10-year flood. We need to calculate the probability that construction site will be flooded in the 2-year construction period. And we also need to calculate the probability that it will be flooded in the first and the second year. Based on the description, we know that it's a 10-year flood. So the return period, it equals to 10. And we can calculate the probability of the flow will exceed 10-year flood in any given year. It equals to 1 over t. It equals to 0.1. And we also list all scenarios of floods in a 2-year period. We have 4 scenarios. Now let's solve the first probability. The construction site will be flooded in the 2-year construction period. Because we know that we can find the flood in scenario B, C, and D. So to solve the first probability, we need to add the probability of scenario B, C, and D together. There is another way to do that. We can calculate the probability of scenario A and then use 1 minus the probability of scenario A. So the probability of scenario A, it equals to 1 minus P to the power of 2. Because 1 minus P is the probability of the flow will not get flooded. And because it's a 2-year construction period, so its power should equals to 2. So the probability of scenario B, C, and D, it should equals to 1 minus this term. Therefore, the P1 should equals to 0.19. Now let's calculate the second probability. The probability that it will be flooded in the first and the second year is we need to calculate the probability of scenario D. P squared. So it equals to 0.01. Now let's move on to the second problem. A city depends upon a well field for its water supply. If the well's yield during the dry season drops below a base level of 8,600 cubic feet per second, various emergency actions begin. We know the exceedance probability of the 2-day drought is 40%, and the exceedance probability of the 10-day drought is 10%. Let's solve the first problem. The probability of having to pipe in water at least once in the next 2 years. To calculate this probability, we can use 1 minus the probability of doesn't have to pipe in water during each of the next 2 years. We can use this equation. The 1 minus P sub 10 is the probability of doesn't have to pipe in water in any given year because it asks us in the next situation in next 2 years. So the power should equals to 2. Then we can get the probability P sub A, it equals to 0.19. Now let's solve the problem B. The probability of not having to pipe in water in the next 2 years. So to calculate this probability, we can use 1 minus the probability of having to pipe in water at least once in the next 2 years. So this probability should equals to P sub A that we already solved. So the equation is 1 minus P sub A, it equals to 0.81. The problem C, the probability of having to pipe in water during each of the next 2 years. So it should equals to P sub 10 to the power of 2. It equals to 0.01. The question D, the probability of having to pipe in water exactly once in the next 2 years. So it contains two scenarios. The first scenario is it needs to pipe in water in the first year, but do not need to do that in the second year. Or they do not need to pipe in the first year, but need to pipe in the second year. So the probability for this question, it should equals to 0.18. Now let's take a look at the third problem. In this problem, we need to calculate a 10-year, 24-hour storm hyetograph for Miami for the time period from 9 to 13 hours. And we also need to determine the peak intensity for the storm. Now let's calculate the hyetograph first. According to figure 11.5, the typical rainfall frequency map, we know that the Miami is over here. Then we can get the rainfall depth, the total rainfall depth. It should equals to 9 inches. And according to figure 11.7, and Miami is over here, we know that the rainfall distribution at Miami is in type 3. So next step, we can use the Excel file. We can download it from the core site to calculate and plot the hyetograph. Here is a spreadsheet that we can download it from the core site. The first thing we need to do is to correct the typo. The value in the block E27 is not 0.5, it should be 0.6. And then we can input the value in the block H1. The total rainfall, it should be 9 inches. We read this number from the figure 11.5. And according to the figure 11.7, the rainfall distribution at Miami, it should be in type 3. So to calculate the cumulative rainfall, we should use the value in type 3 times the total rainfall depth. Then we can calculate the rainfall depth. The rainfall depth at the initial point, the starting point is 0. Then we can calculate the rainfall depth in next duration. We should use the cumulative rainfall in the current duration minus the previous one. So here represent the hyetograph we got from the spreadsheet. Now let's calculate the peak intensity. Now let's back to the spreadsheet. Based on the previous steps, we already calculate the rainfall depth in each half hours to calculate the rainfall intensity, which is in inch per hour. Therefore, we need to use the rainfall depth times 2. Then we can get the rainfall intensity in inch per hour. From this column, we can find that the maximum value, it should equals to 5.436 inch per hour. So we can get the maximum rainfall intensity. It equals to 5.436 inch per hour. So here is a result for the third problem. Now let's move on to the last problem. In this problem, we know the incremental depth of rainfall during a 45-minute storm. We need to determine the total depth of rainfall for the 10-hectare urban watershed, the maximum intensity, and the total rainfall volume. Let's calculate the total depth first. To calculate the total depth, we should add the rainfall depth together. It should equals to 3.81 centimeter. Then we can calculate the maximum intensity. To do that, first we need to calculate the duration. For instance, we use 6 minus 0. Its duration is 6 minutes. And we use 18 minus 6. Its duration is 12 minutes. Then we use the rainfall depth divided by the duration to calculate the intensity. Then we can figure out the maximum value. We find after we do this calculation, we find the maximum intensity is from 18 minutes to the 21 minutes. Its corresponding intensity, it should equals to 9.2 centimeter per hour. The total rainfall volume, it equals to the total rainfall depth times the area. We just calculate the total depth is 3.81 centimeter and the area is 10 hectare. Then we can get the total volume, it should equals to 3,810 cubic meter.